everyone and welcome back to Diksha Karnataka YouTube channel. Today I am going to discuss a very important topic. I know many of you think physics is hard. I will going to show you what is your opinion. So basically we are going to discuss why physics is so hard. Okay, for most of the students, why physics is so hard and how can we improve that so that we can score well in physics. So basically 2 points in today's discussion. First of all the things which makes physics hard, you have to understand that, and secondly you have to understand how you can improve your score. How should you study physics so that you can improve your score despite the fact physics is very hard. So I am going to show you that physics is actually not so hard. It is our perception, our fear of continuous neglect that lead us to the fact that physics is very hard. So before I start, why I am saying physics is very hard? I am not saying physics is hard. It is you who is saying physics is hard. Let's see about a poll that we have conducted in our channel. We have conducted polls in our YouTube channel as well as in our WhatsApp channel. By the way, you have to subscribe to our channel and join our WhatsApp channel so that you don't get miss out on any opportunity, any new updates that is coming through your way. So these are the basic things that you have to do before watching this video. Now we have done this poll in our YouTube channel and we have received this result where it is saying that physics is 61% of the students, those who are saying that physics is very hard. Okay, we almost 1000 students voted for this poll, and from this poll we can see that out of almost 1000 students voted in this, and 61% of them are saying physics is the most difficult subject. Okay, maths, about 25% are saying maths, chemistry only 11%, and biology is obviously 2% students are saying biology is hard. Okay, so most students are easy, they are okay with biology, but 61% students are saying physics is hard. So there is a huge problem in physics. So let us understand that. But before going into that, you have to know that what will happen if you do well in physics. So what is the motivation here? So the motivation is that according to a general survey, 95% students are generally weak in physics. Okay, weak to average. Okay, so 95% students are weak to average in physics, whereas about only 5% students are strong in physics. So this is based on different year wise results analysis. Okay, if you check the analysis of results, you will see that most students are doing well in biology, doing well in chemistry, but not so much in physics. Okay, maybe it is in class 10th exam, maybe it is in class 11th exam, maybe it is in class 12th exam. So all where we are seeing physics is considered to be the most difficult subject. So if you are falling in this top 5% bracket, then obviously you are ahead of the whole group of students. So your future will be better if you somehow improve your physics. Your overall performance will improve, your overall chance of getting successful life in future will improve, right? So that's why that is the motivation. So 5% students are only strong in physics. So if you improve your physics, you will fall in this top 5% students, right? So whether you will stay in the top most of the students where everyone is weak, or you want to improve and be the top 5%, that is up to you. Okay, so my task is to inspire you so that you can be in the top 5%, so that you can score well in physics. You need some motivation, I know, so that is the motivation, right? Now let's see why physics is so hard. We will see point by point. We will explain why physics is hard. It is not very difficult to understand. First of all, physics is a abstract concept. So what is the meaning of abstract concept? We say that there is a particle, there is an object, there is a body, there is a rigid body. So all these things are imaginary things. Okay, if I say an object is moving, a particle is moving, have you ever seen a particle moving in your real life? You have seen a car moving, you have seen a bus moving, you have seen cycle moving, you have seen me moving in the class during I am doing this, right? So but what about a particle? What about an object? what is a body? Okay, what is rigid body? So these are all terms which require certain level of imagination, right? So, and I know this is not very difficult to imagine, but when reading the book you might feel bored that okay, a particle is moving, an object is moving, whereas when you study biology you will see okay, there is a flower, there is a stem, there is this and that, so different parts of the flower, so that is quite obvious and you can see them in your real life. If you take a flower from your college garden or from your home garden or from the roadside, you will see all the parts that you have studied in your biology class. It is not very difficult to understand those concepts, right? In chemistry also there are some chemical reactions that you can do in your laboratory, or sometimes actually you do those experiments in your laboratory and you understand. But in case of physics experiments are also boring. You take a scale, you do some measurement, length, breadth, height, then you measure what is the volume, etc. But what is the need for that? So basically you might feel that physics is boring because all of these things, but actually physics is the most useful subjects, okay, apart from biology for those who want to become a doctor in future and those who are preparing for NEET, even though they also have to be strong in physics to get selected in a government college. So that is that thing apart. Physics is almost everywhere, okay. We are living in a planet, that planet is rotating around the sun, okay. Everything is connected by physics, okay. The discovery, the creation of this universe is based on physics and chemistry, right? So then gravity take place. Gravity took over the world. Gravity is basically a major concept of physics. So all the things that we observe in our day-to-day life are somehow connected to physics, okay. Even biology is somewhat connected to physics in a complicated way, not so simple way, but this is also part of physics. There is a branch called biophysics where you study biology and physics together, right? So those are very interesting topics. So you cannot ignore physics. Only thing that you need a little bit of imagination, okay. You can imagine, okay, a particle means a dot, a spherical dot which is moving, okay. An object means anything. It can be anything. It can be a bus, it can be a car, it can be a cycle, anything, right? So that's why don't think these are very abstract things. You have to relate them to the real objects. So that's it. As soon as you start relating them to the real objects, you are good to go, okay. Now what else? Mathematics requirement. Yes, to understand physics a certain level of mathematics is required, okay. And you have to apply those mathematics so that you can get the result. Right now, not super high level of mathematics required at your level. As you grow older, as you grow higher, okay, the mathematics requirement becomes higher and higher, okay. But yes, certain level of mathematics is required. Now I am going to tell you a story. How many of you know about Isaac Newton? I hope everyone knows, right? No one in this class that does not know about Isaac Newton. Now Isaac Newton, what he is famous for? Sir, what are you saying? Isaac Newton is famous for laws of motion. Isaac Newton is famous for gravitation. Isaac Newton is famous for laws of cooling. Isaac Newton is famous for light. There are many things. Everything he is famous. Now what all are these subjects? These are all physics subjects, right? Now Isaac Newton was a physicist, and certain point of time he realized that whatever mathematics is available to him is not sufficient for him to develop the physics. So he was one of the person who developed the calculus that you are using today. Okay, there was Laplace also involved, but he did it independently. But the part most of us do in our calculus, that was developed by Newton. Okay, so Newton is one of the pioneer who developed calculus. Calculus was basically a core mathematics, right? Then that application of calculus is in physics. So he developed calculus only so that he can apply them to understand concepts of physics better. So understanding of mathematics is essential. I know many of you are strong in mathematics, but still then you are weak in physics. So those who are strong in mathematics, those who are consistently scoring 90% in mathematics, their mathematics base is clear. So only thing that you have to do, you have to relate those mathematics concept to physics. Some student thinks that the mathematics used for physics is different than that of required in mathematics, right? Physics math is different than mathematical maths, but actually it is not. Okay, only thing is that the variables, the terms that we use is different. Okay, the application, it is a physics is an application of mathematics. Okay, but the formulas, the equations, the calculations that we do, both cases they are same. The name is different, the way of solving is somewhat similar, somewhat different. In some cases we require some extra knowledge, but mostly 90% of the times, 99% of the 90% of the cases, mathematics and physics that you are using to solve physics problems are same. Variable names may be different. Okay, the way you approach to a mathematical problem may be slightly different. Okay, in case of mathematics you are dealing with difficult level of mathematical problems. In physics we do not deal with super difficult mathematical problems. Only thing is, okay, you have to put some values. In mathematics the answer is left is abstract, but in case of physics you have to insert the values. So you need to know how to use the values. That's it. Right, so that is the basic requirement. So mathematical requirement is obviously sometimes make the subject difficult, but you have to understand the mathematics and physics are not different. Okay, whatever mathematics you are using in maths, if you have learned calculus in maths, the same calculus is applicable in physics also. Okay, so that is the basic things. Addition, 2 plus 2 is 4 in physics, 2 plus 2 is 4 in mathematics as well. Sine 0 is 0 in mathematics, sine 0 is 0 in physics also. These are the things, but the interpretation is different, right? So sine 90 is 1, that means if two vectors are perpendicular, then their magnitude becomes their dot product is cross product is not 0. So basically there are some different interpretations are there based on the values, right? But mathematics part is same. Okay, now let's look into the next problem. Next problem is problem solving skill and precision and attention to detail. These are the two next problems. So when you are solving problems in mathematics, your problem solving skills are already developed, right? You already solving problems, you are already doing mathematics, so that means your problem solving skills is already there. You are doing problem solving skills, you are using your problem solving skills in mathematics, you are using problem solving skills in chemistry, but why you are not able to use the same thing in physics, right? So you have to do some logical thinking, some clear headed thinking. If you can do that, then you are very good to go. Next is precision and attention to detail. So while studying biology, I have seen students put too much effort. They remember all the scientific names, all the parts, all the small details. But when they study physics, they just read, okay, this is this. So they just do it superficially. Don't do it superficially. Go it little bit in depth. Okay, study it, understand it by heart. Okay, if you understand any concept by heart, then it will remain with you for longer period of time. Okay, now how to understand a concept by heart? By solving some questions, by solving some problems, by practicing. And the last option, which I don't think is super effective, but if you can do the memorization process as well. Okay, to memorize things, I prefer to practice questions based on those concepts. Okay, to solve some numericals based on that concept. So if you study Coulomb's law, instead of memorizing, okay, force between two charges is directly proportional to the product between the two charges, understand the concept. Okay, there are two charges. The force is directly proportional to the product and inversely proportional to the square of the distance. Okay, instead of just doing memorizing the fact by reading it again and again, you just write down the formula. Okay, solve some problems. Then when the time comes, only thing that is that you remember the formula, you remember the problems, you have to translate it into normal words. That's it. So if you can do that, then you are good to go. So don't worry too much about difficulty. Difficult things will be there in life. Okay, you have to at least solve up to medium level. If you can do reach up to medium level of difficulty, slowly once you have overcome the initial hurdle. So remember that once you first cross the initial hurdle, if you start your regular exercise of spending some time with physics, loving the subject, okay, try to start these things. Once you start these things, everything will fall in place. Trust me. Okay, the initial hurdle, the initial stop is the most difficult to cross. Once you cross the initial hurdle, it will be much easier for you. The road will be very smooth for you, right? So try to overcome that. Next, let's see. Conceptual layers. This is one of the most difficult thing to discuss, that in physics only one concept sometimes is not sufficient to understand the subject. Okay, you have to, for example, I will show you some examples, some easier level questions, some difficult level questions which are important. So how to tackle that? So conceptual layers are basically when you have one concept based on the other concept. Okay, so and many of you have ignored your first view. Now you are currently in second PU and you are struggling with multi-level questions, multi-layered questions. Some of you are studying in class 11 PU1 and you have ignored your physics in class 10th, or even you are currently studying in PU2, you have ignored your physics in class 10th because that time there was pandemic and you have not studied many of the important concepts and you are finding it difficult to understand these things right now. So those are the basic things that you have. We call it a backlog. Okay, if there is a backlog developed, then it will be sometimes it becomes difficult for you to understand, but there is a way. What is the way? Your book is self-sufficient, that you have to understand. Sometimes some knowledge required from the past, you can overlook that for some time and you can say, okay, this part I don't know right now, so what I will do, I will go back and learn about the old concept, old part which is missing, which I don't know. Then I will come back and I will study that. You don't need to study the entire chapter. So suppose Ohm's law, you don't need to read, if you are reading Ohm's law in current class, maybe Ohm's law you might find it difficult. So what you will do, you will go back to your class 10th and study the Ohm's law part, only the Ohm's law part. Then you come back and read this book again. That will help you. I'm just giving you an example. Ohm's law is there in your PU2 as well, but right now you suppose your Ohm's law exact definition, exact statement is not there in your class 12th book. So what you will go back to your class 10th book, open electricity chapter, study the Ohm's law part, and then you come back. Or you can what you can do, the easiest thing is search on Google what is Ohm's law, learn that part, and then you can continue read your current subject. So that is the main thing. If you forgot something, you have to remember that and then you can proceed. You don't need to remember everything on that chapter, everything on that concept. Small improvements, small study gap can be very helpful. Okay, next is real world application, and sometimes we might find it difficult to understand what is the real world application of some laws. For example, what is the real world application of Newton's first law, right? So you might think that what is the real world application of Newton's second law? Newton's second law is still understandable, that if you apply force it will move, but object is not moving. What is the basic real world application? So sometimes it is difficult to match our study with real world application, but that is very common. Okay, it is you should not worry too much about it. Sometimes we can find real world application, sometimes we will not find real world application because the application is very deep and very higher order. Even though it is simple law, the application is very deep and very higher level of application that we do not see in our day-to-day life, but it is there. Okay, next is intensive workload. Okay, you have to study physics, you have to study chemistry, you have to study maths, you have to study all the subjects, and in between what you do, since I am weak in physics, I will ignore it completely. Since I have not studied P1 physics, I will ignore it completely. I will only focus on whatever I am studying. Or I will ignore physics completely, I will only study physics, I will only concentrate on chemistry, mathematics and biology, which is very poor decision. And just for your reference, that physics is required either you study engineering or you study doctor, MBBS, you want to study MBBS. So basically the two major common exams, any engineering entrance exams or NEET exam for selection into MBBS, you need physics. So you cannot ignore physics. Okay, so if you want to focus on your engineering career, you may be ignoring your biology. If you want to focus on your MBBS career, you can ignore mathematics, but you cannot ignore physics. Physics is common subject, physics and chemistry is common in both cases. Only if you go towards literature, okay, you are studying science currently, but you realize that you are doing it by mistake, and I want to study literature, I will either study English or I will study Kannada, or I will go to any other language study. Okay, then it's fine, then you can ignore physics. Okay, if you are studying science, any science subjects, okay, engineering, mathematics or pure science, whatever you study, physics is always required. So don't ignore physics. Right, now let's look into few solutions, solution to the problem one by one. So first of all, break down the problems. Okay, so whenever you are solving a problem, you have to break it down into chunks. Okay, like Cadbury, when you eat Cadbury, they don't give you a single bar, right? They give you small pieces. So you can break it, you can have one piece, enjoy it, then once that piece is finished, you can have another piece and you can share it with your friends. Okay, you can take one piece from this, right? Similarly, there are two things that you can do. You can take a problem, whatever problem you are solving, you break it down into small parts. Also you can like you share the Cadbury with your friends, you can share the problem with your friends as well. Okay, so you can discuss, okay, how can we solve this problem? Group discussion, very important. Okay, for the students who are going to appear for Q2, you can discuss concepts between you. Okay, between you two students, right? Sometimes teacher may not be able to explain the concept correctly to you. Okay, but if a student understands the concept, then he can explain the concept in your language so that it is easier for you to understand. Now there is a pro and there is a con for that. The pro is that you will be able to understand that concept easily. The con is that if that student misunderstood the concept, okay, then he or she might explain it incorrectly to you. So your learning will be also wrong. So there is everything has a pro and con. But if that student is good in physics, if he is doing well in physics, you can ask him for help. Oh, you are doing well in physics, can you please help me to understand this concept? I am not able to understand. So speak your mind. That's how you will be able to solve difficult questions, right? So this is the one of the very important point. Break down the problem, right? I will show you one example for that. Connect real life examples wherever possible. Okay, so object is moving on a straight road. You can imagine that there is a highway, straight road, and a bus is moving. So that this is how you can imagine things. You have to imagine, create your imaginations and relate it to the physics problems. Okay, a point charge is moving from infinity to your some point in space. So you can imagine that the sky is infinity and a star like point object which is a shape of a small star, it is slowly moving towards you. So you have to imagine those things. That is a very good way to learn physics. If you are strong in your imagination, it will be very helpful for you to understand physics. Okay, if possible, you can relate it to the exact real life example. If it is not possible, take the real life example and add physics to it. Okay, then it will be very helpful, and you can remember the concepts. You can memorize this without having much difficulties. Trust me, if you, as soon as you start relating things, okay, it will be very easier for you. Okay, next is practice regularly. That's what I said previously also. You should not ignore physics. You have to cross the initial hurdle, right? As soon as you cross the initial hurdle, it will be very easy for you to understand physics, right? Next is, don't be afraid to ask questions. This is the most important suggestion for me, to don't forget to ask any questions. Okay, you can ask the questions to your teacher, you can ask questions to your fellow student, or you can ask students, whoever you think, okay, he can answer this question for me. Your parents, maybe they were also a student sometime, right? And if they know the answer, they will help you. So don't be afraid. Okay, if you are afraid, then you are gone. Okay, so if you are shameful, okay, what he will think about me if I ask the question to him? It seems very easy question to me. Even if this seems very easy to me, that may not be, even if you think this is very easy, but I am not able to understand because I am dumb, don't think like that. Okay, the same thing is applicable to the other student as well. Okay, or same thing is applicable to the teacher as well. Teacher will never ever hurt you. They will always appreciate, okay, some student is coming up and asking questions. So start asking questions today, right? So mention in the comment whatever doubts you have related to physics. I will try to address as much as possible. Okay, so don't be afraid. Start asking questions today. Now let's see few examples that physics is not so hard and it is not so easy either. So you have to spend some time studying this concept. So first question is one of the KCET questions from Kirchhoff's law, current electricity chapter. Kirchhoff's junction rule is a reflection of. So first of all, Kirchhoff's, there are two rules: Kirchhoff's junction rule, Kirchhoff's loop rule. Okay, so you have to break the question down. Okay, now what this question is talking about? This question is talking about junction rule. Okay, so junction rule is based on the conservation of charge, loop rule is based on the conservation of energy. So basically junction rule is conservation of charges. Okay, so this is the answer. So you have to break it down to understand. There are two rules. Junction rule means when the charges are coming from one end, so whatever total incoming charge to up junction, incoming current, same amount of incoming current is the outgoing current. Okay, so if suppose in I1, I2, I3 is coming in, and I4, I5 and I6 going out, and total incoming current I1 plus I2 plus I3 should be equals to total outgoing current, right? So current, now this question is rule is based on the current thing, okay, but if you multiply current with time, then you will get the charge, right? Current is nothing but charge per unit time. Okay, so if you make that time 1 second, then basically you are just adding the charges. So charge is conserved. So junction rule is based on conservation of charges. If you understand this in detail, in depth, in your heart, then you don't need to write this down. You don't need to do this everything. But you have to understand this concept by heart. When you are studying, you have to do this. When you are answering exactly in the exam, then you don't need to do this. You know this. Okay, junction rule is conservation of charges, loop rule is conservation of energy. Okay, now let's look into one more question. This is also a KCET question from the chapter AC. Okay, in Karnataka, the normal domestic power supply AC is 220 volt 50 Hz. Okay, so here 220 volt and 50 hertz refer to. So what is the meaning of these two terms? So if you have seen anywhere, every device, every where you go, they will mention 220 volt 50 hertz. Okay, even if you check your mobile phone, they will say input is 220 volt 50 hertz, output is 5 volt 0.1 ampere. So they have certain level of range. Right now, what is the meaning of this 220 volt? What does it mean? So you have to understand that any voltage, whenever we mention that voltage, is basically an RMS voltage. Unless it is specified, it always refers to RMS voltage. So the RMS value of voltage and frequency, obviously 50 hertz, hertz is the unit of frequency. So this is the frequency of current. What is the meaning of frequency? When current fluctuates, so this is called one fluctuation, right? So from here to here is 1 and from here to here is 2, like that. So in 1 second 50 such waves passes through this circuit. So in 1 second 50 such oscillation pass through a wire, pass through a conductor. That is the meaning of this 50 hertz. So if you understand that this is the frequency, and everything unless specified is basically a RMS voltage. So this is the answer, RMS voltage and frequency. Okay, easy. Now let's look into a little bit difficult question, okay, where multiple layered questions are there. You have to apply more than one concept to understand this question. So this is a question which also from KCET exam. A charged dust particle of radius 5 times 10 to the power of minus 7 meter is located in a horizontal electric field having an intensity of 6 pi times 10 to the power of 5 volt per meter. So what is the question is about? The question is about a charged dust particle. Okay, what else? The radius of the dust particle is 5 times 10 to the power of minus 7 meter, and it is located in a horizontal electric field having, so it is a horizontal electric field. And one more suggestion, whenever you are studying, try to draw the figures, okay, try to draw the diagrams. Unless you are super master of it, when you are solving, if you draw the diagram, it is very helpful, very easy for you to remember and understand as well. Okay, so drawing we ignore, we do that for biology, but we ignore for physics. So if you don't draw it, you will not be able to understand the problem, right? So you have to draw the diagram. So horizontal electric field having intensity is given. So electric field, we generally draw it like that. Horizontal means in the horizontal direction. The electric field of the intensity of the electric field means electric field itself. E is given. Okay, the surrounding medium is air. So whatever the medium is here, that is air. Okay, very common. With a coefficient of viscosity eta equals to 1.6 times 10 to the power of minus 5. So coefficient of viscosity is given. So we were talking about electric field, electric charge up to this point. Suddenly the question changes where they are saying that there is a medium of air present and air has a viscosity of this value. Okay, if the particle moves with a uniform horizontal speed, very important, uniform horizontal speed of 0.02 times 0.02 meter per second, find the number of electrons in it. What? So again they are asking about electrons. Okay, so first they started with electric field, electric charge, then they talked about viscosity, okay, and velocity. Then suddenly they are asking about the electrons in it, right? So first of all, they have not mentioned the charge on the particle. If they have given you the charge on the particle, then this was a very simple problem. We know how many charges are there for 1 coulomb of charge. So 1 coulomb of charge generally have 6.625 or 6.25, I think, if I remember it correctly, 6.25 times 10 to the power of 18. Anyway, this is immaterial for this question. 10 to the power 18 charges, 10 to the power 18 electrons per 1 coulomb charge. So this is the number of charges for 1 coulomb, right? So you know that. Now in this case, how to solve this question? I am not going to solve the entire problem in detail. I will give you the process. First of all, there is a charge kept in an electric field. If there is a charge kept in an electric field, there will be a force acting on it. What is the force? We know that charge acting on an electric field is Q times E. That is the definition. So if you understand that, okay, whenever we keep a charge in an electric field, there will be a force. Now if there is a force, from second law of motion, we know that there will be an acceleration, right? So object will not be able to move uniformly unless there is a force exactly in the opposite direction which cancels this force, right? So here they are saying uniform horizontal speed. So uniform horizontal speed means acceleration is 0. So object does not have any acceleration. So you have to understand the meaning of these intermediate lines. If you understand that, then you can solve these questions. Okay, so uniform horizontal motion means acceleration is 0. That means there must be a force which is opposing this QE. So if you remember something about from the chapter viscosity, that there is something called a viscous force which is given by 6 pi eta rv. Okay, so 6 pi eta rv, okay, this is from Stokes law. This is the force acting on an object moving through a viscous medium of viscosity eta. Okay, v is the velocity, r is the radius of that particle. So radius is given, everything is given, radius is given, speed is given, okay, eta is also given. So what is the question is all about? The question is all about that since this object has a uniform speed, that means acceleration is 0. That means this force should be equals to QE. This QE is acting in the direction of electric field and this viscous force is acting 6 pi eta rv is acting in the opposite direction. Okay, so these two forces should cancel each other so that the object can move in a uniform motion. That's it. This is the logic, this is the concept. If you understand that, you can answer it. Okay, this part is not super difficult to understand. That uniform motion means object has 0 acceleration. 0 acceleration means object should not have any force acting on it. That means whatever the force acting on the system, they should cancel each other. They should be equal and opposite. So we have done that, equal and opposite forces. From here you can calculate Q. So Q is given by 6 pi eta rv divided by E. Okay, so you will get the value of Q in coulombs. Okay, you will get the value in coulombs, or you can say that we know that if there are n number of electrons, then Ne equals to 6 pi eta rv by E. So number of electron is basically 6 pi eta rv divided by E times E. Here E is charge of an electron, that is 1.6 times 10 to the power of minus 19. Okay, now put these values and tell me the answer in the comment below. Which one is the correct answer? If you want the detailed solution, I have done this solution in the chapter electrostatics PYQs. You can check that PYQ video where I have done this solution. Otherwise, if you want, you can solve this video solution and mention this in the comment below. Okay, everything required to solve this problem I have given you. Now this level of expertise requires sometimes. It will not develop immediately. Okay, so that there are two different types of forces acting. So there is uniform motion, that means acceleration is 0. So understanding everything, this kind of understanding requires certain level of expertise, certain level of practice and regular study. Okay, so if you do that regularly, then after 1 month, 2 months, 3 months, you will be able to answer this question as well. So if you remember, I have done how to master physics in 3 months. I have shared step-by-step guide to become a master in physics in 3 months. Here I have shared why physics is hard and how you can master that demon of physics which is very fearful, which is trying to eat you. So don't be afraid, start asking questions, study regularly. Soon you will be very good in physics and you will say that I have achieved a dream in my life. I have scored 90% in physics, which is very beautiful, and you will make us proud. So scoring well in physics is not only difficult, but it is also very rewarding. Right? So even though the physics is challenging, at the end of the day, if you score well, you will be very happy in your mind. Right? Remember that when you scored well in your first exam, when you were a child and you scored 90% in your annual exam, and your parents said, why? Very good. You got A+ in this subject, right? So initial infatuation with generally was there with maths. When you are a kid, your parents generally want you to do well in maths, because it is said that mathematics is the foundation of all the subjects. So parents want you to score well in mathematics, and when you start scoring well in mathematics, your parent appreciates that, right? Similarly, now after initial period, you realize that okay, I am maybe doing well in maths, but physics I am weak on. So physics is now the most difficult subject. So physics is also very rewarding. If you do well in physics, you will not be only happy, your future will be secured. Okay, you can say that okay, in my second PU exam I scored 90% in physics, okay, which is very difficult at that point of time. Right? So nowadays everyone is scoring well in chemistry, mathematics, biology, but physics is somewhat everyone is doing facing difficulty to answer, right? So you have to do well in physics to call yourself a physics hero. So we can share your name that this boy was following our channel and scored well in our in the upcoming PU exam. Then to do that also you have to subscribe to our channel, right? So then only if you score well in your PU exam, we will do a special feature about you. Okay, you can come to our channel and you can talk to us, right? So don't forget to subscribe to our channel and mention your PU midterm score in the comment below, right? So we can discuss. Also, if you have any questions, any doubts, any queries, you can mention that in the comment below as well. And if you want, please share with your friends. If this video is helping you, if our channel is helping you, then don't forget to subscribe. I'll be back with more such videos in future. Till then, bye.